one is formation of differential equation and solution of or solving differential equation or forming differential equation, two types. In this the first type we are going to see is formation of differential equations, for which the general solution is given. So, we know what is the general solution. General solution contains the parameters a and b. A particular solution does not contain any parameters. Okay. General solution of, that is formation of differential equation whose general solution is given. Okay. Let us consider an equation x square plus y square plus 2x minus 4y plus 4 is equal to 0. This equation is a equation of the circle with the center minus 1 comma 2 and radius is equal to 1 unit. So, this is a equation of a curve, that is a circle curve, which minus 1 comma 2 is the center of the circle, radius is 1 unit. Now, let us see how to form, let us take this as the general solution and we form the differential equation. For forming differential equation, what we have to do is we have to differentiate the equation. So, differentiating equation 1 with respect to x. How to differentiate x square, that is 2x, y square differentiation is 2y dy by dx, and then for 2x it is 2, for 4y it is 4y into 4 into dy by dx. This 4 is a constant, so this is the equation. See, we have formed a differential equation and here we can simplify this, x plus y dy by dx plus 1 minus 2 dy by dx is equal to 0. We can separate dy by dx is equal to dy by dx. If you separate it, here it is y minus 2 and here it is, so here x and here 1. So, minus x minus 1. So, dy by dx is equal to this minus, we can take it to this, y not equal to 2 is a differential equation, So, what we have done in this example is we have taken a solution of a differential equation and then we have formed the differential equation by differentiating. So, forming is just nothing but differentiating the given function and then eliminating all the constants. Here there is no constants are there, parameters, constants means parameters are there. So, this is a differential equation. Let us see some more cases, some more examples for this. Consider x square plus y square is equal to r square. So, this is the general equation of the circle whose center is at the origin and radius is small r. Center is the origin and the radius is small r. Now, by taking different values for r, we get different circles, that is we get a family of circles. Let me take some circles here. X square plus y square is equal to 1, x square plus y square is equal to 2, x square plus y square is equal to 4. Now, I will draw these circles. All these circles are concentric circles with the center at the origin and radius, different radius. 1 r square is 1, 2 and 4 like that. So, this is this equation represents equation of concentric circles. You can see this circle, you can take it as x square plus y square is equal to 1. This circle we can take it as x square plus y square is equal to 2, and another circle, the third circle is 4. Like that we can do, depending by giving different values for r, we can get different circles. So, this equation represents a family of circles. Now, we want to find a differential equation to represent this family of circles. What we want to find? A differential equation to represent this family of circles. In that, there should not be any r. So, r should be eliminated. Why? Because r takes different values for different circles, but we want to find a differential equation to represent the entire family of circles. That is, let us see what we have to do. Let us keep this as equation 3. In the equation 3, let us differentiate this. Differentiating 3 with respect to x, differentiating 3 with respect to x. How to differentiate x square? We have already seen that 2x, y square we have to differentiate 2y into dy by dx is equal to r is a constant. So, it is differentiation is 0, r square is 0. Now, this is x plus y dy by dx is equal to 0. This is the fourth equation. This equation represents this family of circles. This equation, differential equation, represents this family of circles. That is, it represents all the circles in the family. All the circles in the family it represents. Here you can see there is no r in the final differential equation. So, this is how we have to form a differential equation. Here r is called a parameter. There is in our the present case we have only one parameter. So, we have differentiated first order derivative and we got 0. So, in the previous classes I have told you, whenever two parameters are there, then we need two successive differentiation, that is dy by dx and d square y by dx square is required for us to eliminate all the constants. Here we have eliminated the constant by just differentiation itself, we got eliminated. Now, let us see another case. Consider y is equal to mx plus c, where m and c are parameters. I think all of us are familiar with this y is equal to mx plus c. It represents a straight line. Okay. Now, let me take different straight lines here. Y is equal to x. For this, m is equal to 1, c is equal to 0. For this, m is equal to 1 and c is equal to 0. Y is equal to root 3x. Here also, m is root 3, c is equal to 0. Now, let us take y is equal to x plus 1. M is equal to 1, c is also equal to 1. Let us take y is equal to minus x. M is equal to minus 1, but c is equal to 0. Y is equal to x minus 1. So, we can by assigning different values for m and c, we can get any number of different the equations of the form y is equal to mx plus c. in the last equation you see m is equal to 1 and c is equal to minus 1. Now, this represents, these equations represent family of straight lines. These equations represent the family of straight lines. You can see first equation is, I will draw this y is equal to x, and the second equation there is y is equal to root 3x. That also passes through the origin. Y is equal to minus x. So, this will be like this, y is equal to minus x, and y is equal to x plus 1. How, where the line will be there, y is equal to m x plus 1. So, m is equal to 1, c is equal. So, you can put here x is equal to 0, y is equal to 1. So, this line is like this, and when y is equal to 0, x is equal to minus 1. So, this line is, this is also y is equal to x plus 1. So, similarly, we can draw the other line also, y is equal to x minus 1 line we can draw. So, this equation, by assigning different values for m and c, represents a family of straight lines, Now, we want to find a differential equation which represents all these straight lines, or which satisfy the equation of all these straight lines. For that, what we have to do, in the previous problem what we did, we have to differentiate. So, let us take this as equation 5. Now, differentiating 5 with respect to x, differentiating equation 5 with respect to x. How to differentiate this? Dy by dx is equal to m. So, this is, let us take this as equation 6. Still, on first order derivative, this m is a parameter. We do not want m, because in the final differential equation there should not be any parameters, because m will take different values. So, what we have to do? Again differentiating 6, we get d square y by dx square is equal to 0. Now, d square y by dx square is equal to 0, there is no parameter. Therefore, it represents all this family of straight lines. D square y by dx square represents all these values, this family of straight lines given on the board. So, for different values of m and c, you get different straight lines, but this equation does not contain m as well as c. Both the arbitrary constants m and c are eliminated. So, what is the method of forming, what is the procedure for forming differential equations? What is the procedure? First, we have to differentiate. If there is one constant, one differentiation is enough. If two parameters or two variable constants are there, then we have to differentiate the given equation twice, and then eliminate from these equations. We get 3 equations. Here we have got this equation and these 3 equations. You see 5, 6, 7. In this we have to eliminate it, but in this here it is automatically eliminated. So, we need not have to worry. We need not have to solve this equations 6, 7 and 5 to eliminate m and c. But in the actual problems, we will be requiring some idea about how to eliminate the parameters after differentiation, first order derivative and second order derivative. We will get 3 equations. From 3 equations, we have to eliminate the parameters. Then we will form the differential equation. Let us see examples now. Next. So, just now I explained you formation of differential equation. Now we are going to see some examples. Form the differential equation representing the family of curves y is equal to mx, where m is an arbitrary constant. So just now we did the y is equal to mx plus c. Now we are going to do y is equal to mx. So the given equation is y is equal to mx plus 1 mx. So differentiating one with respect to x, differentiating 1 with respect to x. How to differentiate this? Dy by dx is equal to m into x. M is constant, differentiation of x is 1, therefore we get dy by dx is equal to 1. So how to get the differential equation? We have differentiation is over. Now we have to eliminate m from 1 and 2 to get the required equation. Eliminating m from 1 and 2. Here it is very easy. We can easily eliminate this. See, m is equal to dy by dx. We can substitute m in the first equation. We can substitute m from the second equation to first equation. What do you get? Y is equal to dy by dx into x. So this can be taken as x dy by dx minus y is equal to 0. So this equation does not contain the parameter. It does not have the parameter m. So this is the required differential equation. How you have to write the answer? Since the arbitrary constant m is eliminated, equation 3 is the required differential equation. Equation 3 is the required differential equation. Since the arbitrary constant is eliminated, 3 is the required. This is not the required differential equation. This is also a differential equation, but here m is there. So formation of differentiation, we have to eliminate the arbitrary constant. Okay. So this is the procedure for that. Then we will go to the next question here. Form the differential equation representing the family of curves y is equal to a sine of x plus b, where a, b are arbitrary constants. Both a and b are arbitrary constants. So two constants are there. Here to eliminate two constants, we have to successively differentiate the equation, the given equation. So the given equation is y is equal to a sine of x plus b. Now we will do this. First one. Now differentiating with respect to x, both sides. Differentiating with respect to both sides. Now here, what is this? Dy by dx is equal to a into cos of x plus b. How to differentiate sine of x plus b? Differentiation is cos of x plus b into chain rule. Differentiation of x plus b, that is 1 plus 0. So it is 1. So we don't write that. So this is the second one. Again two constants are coming here. So what we have to do? The second equation, two constants. We cannot eliminate two constants from two equations. We cannot eliminate. So we need one more equation. For that, again differentiate 2 with respect to x. Now differentiation of dy by dx becomes d square y by dx square. And what is this? A is a constant. What is the differentiation of cos of ax plus b? Minus sin of x plus b into 1. So, this is minus a sin of x plus b. So, you can see what is a sin of x plus b, that we can take it as y. So, this is the technique used for formation of differential equation. You have to always look into this. A sin a x plus b is y. Therefore, d square y by dx square plus y is equal to 0 is the required differential equation. This is the required differential equation. So, we have formed a second, we have eliminated in the first question, we eliminated only one parameter. In the second question, we have eliminated both the parameters a and b. A and b are constant. So, when we start differentiating, automatically we have to see this a sin x plus b is nothing but y. So, both the constants get eliminated by substituting y for a sin x plus b. So, our work is to eliminate the parameters and arrive at the required differential equation. Now, let me go to the next question, which is ellipse, and form the differential equation representing family of ellipses having foci on x axis, Now, I will draw one ellipse with the foci on x axis center at the origin. What is this ellipse? You can see foci on x axis. So, this is one ellipse. So, family of ellipse, how it will look like? So, it will be for different values of a and b, we get a different ellipse. So, this is a family of ellipses, the family of ellipse, origin, the foci, S dash is the foci. Now, x axis, y axis. We all know the equation of this ellipse. They have not given the equation. So, we should know what is the equation of the ellipse having foci on x axis and center at the origin. So, the equation of the ellipse is the given ellipse is x square by a square plus y square by b square is equal to 1. So, you can see here two constants a and b are there in this equation also. So, if you have three constants, we have to eliminate three constants. We have to go for third order derivative d cube y by dx cube, etc. Now, for our study only two constants are there. Now, differentiating with respect to x, 2x by a square, 2y by b square dy by dx is equal to 0, because constant 1 differentiation is 0. Now, we have to be very careful in this type of elimination of a and b. It will be tedious, otherwise we have some idea about this. Now, what we are going to do, you just watch carefully. That is 2y by b square dy by dx is equal to minus 2x by a square. I am going to take one advantage. I am going to keep variables on one side and the constant on the other side. That can be done easily here. How to do this? You can see y by x, x I am taking here, b square you can take it, minus b square by a square, y by x, 2 cancels, dy by dx, is equal to minus b square by a square. So, before going to the next step, we have to simplify. We have to simplify this, and to take advantage, if all the constants are one side, in the next differentiation, the differentiation of constant is 0, they get automatically eliminated. Both a and b will get eliminated. We can see differentiating again 2 with respect to x. With respect to x. Now, you have to take this as first function, this as second function, y by x as first function, dy by dx as second function. So, y by x into differentiation of second function is d square x by d square y by dx square. dy by dx differentiation is d square y by dx square. Now, you keep second function as constant and differentiate the first function. How to differentiate y by x? You have to use quotient rule, x square x into dy by dx, x into dy by dx, numerator square, denominator square, denominator into differentiation of numerator minus numerator into differentiation of denominator. In the right hand side, minus b square by a square, the differentiation is 0. Now, we have eliminated the constant. If you simplify this, then we are going to get the required differential equation. How to simplify? You can see this. How to simplify this? You can see, you can simplify this and complete the work. Now, x square, you can multiply by x square. Throughout the equation, multiply by x square. What do you get here? Multiply by x square. Here you get xy d square y by dx square, xy into d square y by dx square. So, if you multiply here, what are the things that we are going to get? Here dy by dx is there, dy by dx, dy by dx, dy by dx whole square. So, x into dy by dx whole square. Next, what is dy by dx? Minus y into dy by dx. So, x square gets eliminated because we are multiplying it by x. Here x square, if you multiply x square by x, which is x, you will remain, one x will be remaining, xy into d square y by dx square, and here this gets cancelled. So, only we have to multiply this x into dy by dx whole square minus y into dy by dx is equal to 0. So, this equation 3 is the required differential equation, is the required differential equation. Okay. Then we will go to the next questions. Examples, still some more examples are there, we will see that. Let us see the next example, which is form the differential equation of the family of circles touching x-axis at the origin. So, equation is not given. So, we have to write our own circle equation which touches the origin, touching x-axis at the origin. So, I will draw one circle here touching x-axis at the origin. So, this is the representative circle for the family of circles here. What is this one? You can see what is the equation of the circle. The equation of the circle is equation of the circles is here. What is the center of this circle? 0, a. If you take a as the radius of the circle, if a is the radius of the circle, center will be, see, this will be the radius. When circles touch the x-axis, this will be the radius. See, different circles can be drawn touching the x-axis at the origin. You see, different circles can be drawn. So, we get family of circles touching the x axis at the origin. All of them will have center as 0, a will be different for different circles, a will be different. So, radius also a. So, what is this? X square plus y minus a whole square is equal to a square. So, this is the equation of the circle, x minus h whole square plus y minus k whole square is equal to r square, radius square. Now, we can simplify this equation before differentiating and eliminating a. Y square minus 2ax plus a square is equal to a square. So, x square plus y square minus 2ax is equal to 0. So, this is the given equation of the circle. So, this is also called the general solution of the differential equation. Now, we have to go for differential equation, forming the differential equation. For that, what is the first step? We have to differentiate. The equation. So, differentiating with respect to x, 2x, x square differentiation is 2x, y square differentiation is 2y dy by dx. What is the differentiation of 2a? 2a is a constant. So, 2a multiplied by function x. So, minus 2a into x is equal to 0. Now, 2 is we can eliminate from all the terms. Now, this will become x plus dy by dx minus a x is equal to 0. Now, this is the second equation. From this equation we can take a is there. What is a for from this? We can, what is a for this? Here a is equal to x plus y dy by dx by x. Keep this as equation 2. So, substituting a from 2 in equation 1, we will be eliminating, substituting a from equation 2 in 1, we will be eliminating a. So, what is this? X square plus y square minus 2 into a. A is x plus y dy by dx by x. Then x square plus y square minus 2ax is equal to 0. So, this is the required differential equation here. Minus this differentiation, you can see we have made error, x is 1. So, a is 1. So, here we do not get. What is a? A is x plus y dy by dx. Now, let us take this, simplify x square plus y square. Here 2 y square minus 2a into x is there. So, minus 2x square minus 2xy dy by dx is equal to 0. Now, we can eliminate one x square, that is y square minus x square minus 2xy dy by dx is equal to 0. So, equation 3 gives us the required differential equation. So, this is the required differential equation. So, we have to eliminate constant here when we differentiate this, minus 2a into 1. So, we get 2 can be eliminated, x plus y dy by dx is equal to minus a. So, we take it to this side, it will become a. So, a is equal to x plus y dy by dx. So, substitute this a value in this equation, we can eliminate a and arrive at the required differential equation. So, this is a very, very important question. So, many times in the entrance examination also they have given, and in the board examination also repeatedly they are asking this question. Next question, let us see, form the differential equation of the family of parabolas having vertex at the origin and the axis along the positive direction of x axis. Now, one parabola let me draw like this. What is the parabola here? You see, vertex at the origin and the axis, this is the axis and this is the vertex, vertex at the origin. What is the form of this parabola? Y square is equal to 4ax. Now, different parabolas we can draw depending on the value of a. For the value of a, we can draw different parabolas. We get a family of parabolas. So, the equation of the parabola is y square is equal to 4ax. Y square is equal to 4ax. You can take y square is equal to ax also, there is no problem. So, constant a, one parameter is there, we have to eliminate that parameter. How to eliminate this parameter? Let us see. Differentiating with respect to x, 2y dy by dx is equal to 4a, 4a into 1. So, what is the, how to eliminate? Eliminating a from equation 1 and 2, very simple. 4a is 2y dy by dx. If you substitute it here, 4a gets eliminated. So, that is y square is equal to 2y dy by dx into x. So, the differential equation is y square minus 2xy dy by dx is equal to 0 is the required differential equation. So, one constant only first derivative, one constant we get. If two constants are there, we have to go for successive differentiation, then only we will be able to eliminate both the constants. So, 5 problems we have completed. So, the first 2 problems it is a straight line and y is equal to, second problem is y is equal to a into sine of ax plus x plus b. Then the ellipse problem, circle problem and parabola problem. In this only they will ask 3 marks questions is there. So, another in the exercise we have got 10 problems with the 2 entrance examination problems. Let us go to the exercise 9.3, form a differential equation by eliminating a and b. So, we have seen this ellipse, but this is a straight line with the 2 constants. It is a, what is this form of straight line called? Intercept form of straight line. So, where a and b are x and y intercepts. Now, take this as equation 1, differentiating with respect to x. So, 1 by a plus 1 by b dy by dx is equal to 0. So, dy by dx is equal to, what is dy by dx? Minus 1 by a by 1 by b, that is equal to minus b by a. Keep this as equation 2. So, differentiating again with respect to x, differentiating again with respect to x, we get d square y by dx square is equal to 0. So, equation 3 is the required differential equation, because equation 3 does not contain the parameters a and b. Okay, then we will continue the next problems in the exercise. Go into the exercise problem, second problem, formation of differential equation. They have given a function, so we have to differentiate it and eliminate constants so that we get the required differential equation. How we are going to do this? Let us see. Y square is equal to a into b square minus x square. So this we can write it as ab square minus a x square. Keep this as equation 1, because ab square is a constant and only we have to differentiate minus a x square. Now differentiating with respect to x, this is 2y y dash is equal to, this is 0 minus a into 2x, or y y dash is equal to ax. This is the second differential equation. For eliminating two constants, we need the second order derivative also. So we have to again differentiate. Differentiating again with respect to x. How to differentiate y y dash? You see, y is the first function, y dash is the second function. Differentiation of y dash is y2 dash plus product rule we are using, y dash into y dash, because differentiation of y is again y dash. This is equal to minus a. So this is the differential third equation. So eliminating a from 2 and 3. So minus a we can directly substitute. What is the substitution here? Y y dash is equal to second equation, minus a value is y y2 dash y dash whole square minus a is that into x. So y2 dash y dash whole square into x. So this is the required differential equation. So the differential equation is, you can write it as x y y2 dash plus minus x y y dash plus x into y dash whole square is equal to 0 is the differential equation. So we have eliminated a. We cannot simplify this further, because there is no common values. X is the common for this. For this there is no x. Okay. Y y dash there is no x. For only these two, x is there. No common variables there. So we cannot simplify further. So that is the given differential equation. Next, let us see this question. Y is equal to a into e power 3x plus b into e power minus 2x. Let me take this as 1. Now, differentiating with respect to x, equation 1, this is y dash is equal to, what is the differentiation of e power 3x? 3 into e power 3x. So 3a e power 3x. What is the differentiation of this e power minus 2x? Minus 2b into e power minus 2x. So second equation. Because the two constants are there, we have to again differentiate this. Again differentiating with respect to x. y2 dash is equal to, see here we get 9a e power 3x, then plus 4b e power minus 2x, this is 3. Now we have to eliminate from these three equations a and b. So there we need some algebraic techniques. See what I am going to do is, I am going to subtract 3 minus 2 equation. 3 minus 2 gives y2 dash minus y dash, in the left hand side y2 dash minus y dash. In the right hand side what we are getting, you see 9a minus 3a, so that is 6a e power 3x. Here 4b minus of minus 2, minus of minus 2, so it will become 6ab e power minus 2x. So this is nothing but 6 into a into e power 3x plus b into e power minus 2x, that is equal to 6y. So how we are eliminating, you can see y2 dash minus y minus 6y is equal to 0 is the required differential equation. So we have to do like this, elimination of a and b. We have to follow same technique is not there for each problem of a and b. How to eliminate? We will get three equations. In the three equations we have to use our idea to eliminate a and b. Now next question is y is equal to e power 2x into a plus bx. Now let us keep this as 1. So differentiate with respect to x. Y is equal to, first function is e power 2x. The second function here is a plus bx. So a is 0, b into 1. Next a plus bx into 2 into e power 2x. 2 into e power 2x. So how to simplify this? You can easily do some work here. See, this is b into e power 2x plus this is 2 into e power 2x into a plus bx is y. So that is y. This is y dash. So y dash minus 2y is equal to b into e power 2x. Keep this as equation 2. Since we have got two constants, we have to again differentiate this equation 2. Again differentiating 2 with respect to x. Now the left hand side differentiation is easy. y2 dash minus 2y dash is equal to, b is constant, b into 2 into e to the power of 2x. Now we can eliminate b from, we can eliminate b from 3 and 2. So number of methods you can use. Here b into e power 2x is there, here also b into e power 2x. So you can substitute and eliminate. How to eliminate this? You see, eliminating b from 2 and 3. Now I will substitute this 2b e power 2x y dash minus y2 here. That is y2 dash minus 2y dash is equal to 2 into y dash minus 2y. So this is equal to 2y dash minus 4y. Therefore y2 dash minus 4y dash plus 4y is equal to 0 is the required differential equation. So, different techniques we are using for eliminating A and B. So, each problem is different, and we should have, after differentiation, the concept, that is differentiating first order, second order for two constants, and then we get 3 equations. From 3 equations you have to think about how to eliminate the constants. Now, we will go to the 5th question here. 5th question is y is equal to e power a x. I will see this question, e power a x, a cos b x, a cos, there is no e power a x, let us take only e power x. So, e power x into a cos b x plus b sin b x. I will write this as y into e power minus x into a cos a cos x plus b sin x is given in the book, a cos x plus b sin x. So, it is a simple question. So, differentiation, we can write this equation as first equation, that is e power x. When it comes to this side, it becomes e power minus x. Now, we can start the differentiation, differentiating with respect to x. Okay. Here product rule we have to use. So, what is the differentiation of y into e power minus x is minus e power minus x plus e power minus x into y dash is equal to, here a cos x differentiation is minus a sin x, a cos x differentiation is minus a sin x, b sin x differentiation is b cos x. This is the second equation. So, we cannot eliminate with the 2 equations, we cannot eliminate 2 constants. So, we need one more equation. To get one more equation, we again differentiate this, differentiating 2 with respect to x. So, let us differentiate this. Here we have got e power minus x is common, or if you want to differentiate y into minus e power minus x, this will become e power minus x. So, minus e power minus x into y dash, again same e power minus x. So, y dash into minus e power minus x plus e power minus x into y2 dash is equal to minus a cos x minus b sin x. Now, e power minus x is common in all this. So, take out e power minus x, y, first y is there, minus y dash, again here also minus y dash plus y2 dash is equal to minus of a cos x plus b sin x. This e power minus x we can again take it to the other side. So, now you get y2 dash minus 2y dash plus y is equal to minus e power, when it comes to this side it becomes e power x. So, it is, so do you understand this step? When e power minus x, you take it to the other side. Why we are taking it to the other side? Because e power x into a cos x plus b sin x is y. So, we can write this as y. So, y2 dash minus 2y dash plus 2y is equal to 0 is the required differential equation. So, how to eliminate in different problems. This is a trigonometry is involved. So, you keep this e power x to this side and then differentiate it, again differentiate it, we will get again y in the right hand side. So, both a and b will be eliminated in the last step. So, we arrive at the differential equation y2 dash minus 2y dash plus 2y is equal to 0. Okay. So, we will continue with the next questions.